This is the second video for the October 21st class that is going to focus on the summarize within tool. The lessons that we learned in the last video and this one as well will also work for another tool somewhere in here. I'm going to be a little too lazy to find it, just called sort of summarize nearby. It's the same general concepts, except in that instance, you would be doing the summaries based on proximity, just like a spatial join closest. Last video, right, we took the catchment area, and those catchment areas here, we were summarizing some sort of crime data that was within them. But what we want to do now, what I sort of teed up in the last video, and I created a new selected layer and made it pink just so you could visualize, is like it's logical, like the crimes thing, or not just crimes, but points make sense, right? Because the more we sort of zoom in, on points, like they don't really hit the boundary, you know what I mean? Like it's pretty clear where a point is, right? Some are in this catchment area, some are in that, right? So doing those summaries is straightforward. But that's not the case often with polygons, right? But this is sort of maybe one of the most common things you would use like a spatial join and a summary for, is you would be finding and taking like a common applications to take like census tract data and summarize it by a non-formal boundary, like a neighborhood, or a buffer that you've drawn or something. And you're always going to run into this challenge where I've got two catchment areas here, both of which share this. And so what do I do with like a spatial join? Because if I do intersect, might give its values to both. If I do sort of within, it's not within either, so its values go nowhere. If I do centroid, right, maybe it gives more to one than another. What's a better way, right, where maybe I could actually proportionally allocate the parts of this neighborhood to each catchment area depending on how much overlaps? And if you're not going to use this tool, you'd have to take a much more roundabout way, right? You might do some intersects, and then you do some dissolves, and then you would do some joins. And that's what's going on behind the scenes here. But what we're going to learn is how to actually do it in an automated fashion with summarize within, and what really cool outputs it allows you to give when you're using summarize within to summarize one type of polygon within another. So let's open it back up again. Again, any time you're using this tool, the input polygon, it's the area, right, the boundary, the polygon that you want the summaries to come back in. And in this instance, it's catchment areas, right? I want to know the catchment areas, and I want to summarize the neighborhoods within them. Catchment areas, neighborhoods. Cool? You would then sort of save this. Oh dear, I've already saved mine just because it takes a little bit to run this tool. But you want to give it sort of a name here, like catchment summarize hoods or something. Now, this is an instance, right? If I open the neighborhoods shapefile to show you, when it actually might be useful to have a summary field, because in the neighborhoods we do have quantitative values that I can perform a descriptive statistic on. I have population, I have ownership, I have rent, I have burglaries, right? I have square miles, which is only calculated for sort of some of them. I think perhaps when you're using this video, you'll see it for sort of all of them. It'll become clear in a second why it's only calculated for some. But again, when you see it, square miles, I think will be filled with in for sort of all 158. But each of these I could summarize. And so that's what we might put here, right? Is let's take population, and we'll take ownership, and we'll take rental. We'll just keep it simple and do those three. And then we'll come to statistic. And this probably is the only limitation, in my opinion, to this tool, right? The benefits we're about to gain through what this does for you vastly outweigh this. But the fact that you can't have a median, for example, here, right, or a mode, or some of those other deeper statistics that you can do with spatial join, It's not a terrible limiting factor, but in those instances where, right, you do want to know the median value, you're going to have to use sort of spatial join, because this just permits sort of these 4 key ones. But right now what I want to know is sum, right? I effectively want to summarize the population, the ownership, and sort of the number of rental units from each neighborhood into the respective catchment area. Now, notice what became available to me here that's really, really key. Shape unit didn't pop up before because I was summarizing points. But the minute you summarize a polygon, this is available to you. And what this is going to do is it's going to spit back out to you the number of square miles or square kilometers, whatever you pick. We're going to pick square miles. It's going to spit back the square miles of each neighborhood, right, or of each summary polygon that fit within each. And that's really cool, because that's what we're going to be able to use when I sort of show you how to interpret this, to effectively take the values from Brewerytown neighborhood here and allocate them proportionally to different catchment areas depending on the size. So for right now, let's do square miles. Right, but again, if you were working in meters or kilometers or acres, you would pick those. Finally, we want to go to group field. And you wouldn't have to here, but I do want you to pick name. And there's going to be a reason I want you to sort of pick name, because just sort of some of the outputs that it gives us are going to help us interpret how we get to what the ultimate values that come back to us are, right? So I sort of need this. So again, add the minority, add the group percentages, map name summary is what I'm naming it. Already got it here. You just sort of name it that. And then you'd come over here and you would hit run. Now, it's going to spit out 2 things for you, right? You're going to have a map name summary, and you are going to have something that I've already pre-prepared. Once these things load. That when I go to my polygon examples, you're going to have something that would be catchment neighborhoods. Now, I'm going to open its attribute table very quickly, and then we're going to focus in on just sort of one area so that I can really show you what happened and why it's cool. So we're going to come in, we'll come over, looks the same, and similar elements that sort of happened when we summarized the sort of crime point data, right? What do we got? We have population summarized, ownership, the renter field is. We effectively have an area, right? So that's interesting, kind of telling me sort of the ultimate area of the total polygons that are summarized, the number of polygons I found, and then effectively the neighborhood polygon that was, most or least overlapping with sort of each boundary. The first thing that should be causing, not alarm bells, but, your curiosity. What was that thing from Stranger Things? Curiosity something. I'm kicking myself for not remember. I love that show. But your curiosity alarm to go off. How in the world is the total population that came from neighborhoods into the Bartram's High School catchment area, how the heck does that have a point? So that should immediately be telling you that some sort of math or mechanics are going on behind the scenes. And so what I've done to highlight this is I just selected one, right? I selected the ID 11, join ID 11, Strawberry Mansion catchment area. And to really test it, I did a select by location, and I picked all of the neighborhoods that touch it. And we're going to focus in on just these 2 things, as well as the map name summary table. And doing this is going to help us really see what this tool did, how it worked, and why it's so darn cool. So let's open all 3 of them now so we can pop between them. And again, you didn't see me do this, but if you want to follow me and sort of what I'm doing, you would come in here and select out the Strawberry Mansion catchment area. It's the one that if you scroll has join ID 11. Came in and practiced a select by location, select neighborhoods that intersect Strawberry Mansion. And then I sort of made that its own layer. And then I'm opening the map summary table. So a couple things I want us to do here, right? So first, let's sort of see, what did this give us? Okay, so the sum of the population here is 46,549. So let's like first test, okay, did the way it worked there, did it just sort of take the population, of all 10 of these neighborhoods that intersect it? I don't know, let's test, right? We have the 10 neighborhoods here, and I could come to the population 2010 and I could do statistics. And it's going to come up, and immediately I'm not going to be right? Because the sum is 86,000. So it didn't do that, right? It didn't just take the values of each of these that it intersected, right? That would have happened if you'd done a spatial join and if the relationship you picked was intersect. So that wasn't sort of it. So in order to get there, maybe what I want to do is actually, open up the sort of map name summary and start to sort of look, at the data more granularly. So why don't I then here, find that same join ID, right? Join ID here we know to be 11. So I'll come into map name summary and I'll go to select by attribute, map name summary, and I'll say where the join ID is equal to 11. Right? Curiosity bell should be going off. Where's that number 10? Where did we see that before? Oh, the neighborhoods. 10 neighborhoods. 10 neighborhoods. Oh my goodness, they're the same. Allegheny West, Brewery Town, East Park, Glenwood. Allegheny West, Brewery Town, East Park, Glenwood. Right? So this table is effectively telling me for join ID 11, which is this catchment area, these are effectively all the neighborhoods that touched it that I'm going to consider. Notice, though, when I look at one like Allegheny West, the actual size of Allegheny West is 1.155644 square miles. But in the join table, it's telling me it's only that. Effectively, what that's saying, and I'll sort of select Allegheny West so we can see it up here, it's telling me that of the 1.155664 square miles, about 0.888 intersects me. So let's actually open an Excel thing and do that math, right? If we know that 0.88824 intersected for Allegheny West, and we know that in the shape file, its actual size right here is 1155664. Adding those together gives me this, right? Roughly 76.86% of the area of Allegheny West overlaps here. So if I come in and then I take from the shapefile the population, which was 14,249, and what if I apply that same percentage, right? 76.8% of my area. What if I also calculated 76.8% of that? I'd get, 1,000 or 10,952 and some change. And there it is, 10,592 and some change. Now the change isn't perfect. This would just be down to, I think maybe one was calculated area geodesic and one is this, but we're talking fractions of a point here, so it's totally okay in the example. But there it is. That's how this happened. 0.88 square miles of Allegheny West, which is 1.15 intersected. That equates to 76.8%. Therefore, multiply 76.8% to the total population of Allegheny West, and you get 10,952. Duplicate that same process for each of the other neighborhoods that intersect, and that is ultimately how you get to the point where you can say, this is the population. That's awesome. What a cool tool. What a cool summary that allows for this inconsistency when things overlap, right? Normally you would have to intersect, and then you would have to do some fancy operations with dissolves and joins and summaries to get this, but all that's going on behind the scenes. And of course it's not perfect, right? We may know in some instances here, like this is probably actually a good example, that this neighborhood here, let me see if that lines up, right? This one right here may have a good portion of its area that is parkland here, right? A lot of that is sort of parkland, but it would still be sort of equally proportionally treating its area in a weighted geometric sort of fashion, right? Even though maybe most of the population might actually be clustered in an area here where there's more housing, right? So it's not perfect, but it's way better than just doing sort of like a select intersect and sort of calculating. You're actually using the percent that overlapped when you did the summary and applying that same percent to any of the fields that you summarize. So it's a really, really good tool for getting a more accurate estimate when you want to take some kind of like demographic information that happens at a census tract and join it to a neighborhood or a buffer you've created or some type of irregular polygon that doesn't perfectly line up. And like we saw before, the same cool thing can happen here is you can then, just like we did last time, for each of those catchment areas, we can also know, right, how much of that catchment area is composed by Allegheny West and Brewerytown and North Central and Sharswood. So like a totally other kind of analysis, right? We know that this catchment area has 10 different neighborhoods that are within it, and we know that the neighborhood that's mostly within it is Allegheny West, 24%, and the one that's least, is, I think, not Sharswood, but West Park with sort of 0.286%. So just an awesome, excellent tool, right, that lets you summarize points or polygons and that has a built-in mechanism, right, to intersect the polygons and then summarize the values based on the same geometric weight, right? So whatever percentage of this selected polygon that is inside the black line, that percent would be applied to every field and helps you create your summary.